the same
That's amazing. I love it.
template every single time. I think it's kind of fun. A
That's
little
perfect.
different than some of the other stuff.
All right. So
Okay,
Tyler, where do you go?
cool. Okay. Hello, everybody. Yep. So today I'm talking about Elixir releases and deployments. Originally, it was just going to be about deployments, but then I put that presentation together and it was just way too short because there kind of isn't that much to say. A lot of the deployment stuff is quite, I would say, like bespoke or dependent on where you're working or the hub project you're working on. And I didn't want to get too much into like the nitty gritty details of how exactly we do it. I wanted to do kind of the overarching stuff. So for that reason, I also included a whole section about releases because I think they're kind of interesting and a lot of people don't know that much about them. So here we go. So the first question is why releases? I know that there's some people here who just run, you get your code onto some machine and you do mix run or mix run no halt. And then, your app runs and it's serving traffic. Like, why do you even need to package it into a release? And the Elixir docs, like the getting started guide, they have a bunch of points they list, but three are the ones that, or there's three that I relate to the most in kind of my day-to-day work. The first and the best one is probably that a release is fully self-contained. So if you're familiar with Go and how it packages things into like a binary, so it makes like a million different binaries, and there's like one for any kind of a system you'd want to run on. This isn't really like that. It's self-contained in a slightly different way. What they mean is that, well, since Erlang runs on a virtual machine, we're going to package that virtual machine in the release, and then we're going to pull in all your modules and your config, and we're going to give you that kind of thing that you can then run wherever you want. So even though there's kind of more to it, it's still all self-contained, which makes kind of deploying and running this code a lot easier. A release also preloads modules. So by default, if you're, for example, running your code locally, you say mix run, you're doing some development stuff. Say you're running a Phoenix application, none of the modules are actually pulled in until they're needed. And you may have seen this before if you've ever been playing around with macros or have any compile time stuff in your module. So for example, if you have a Phoenix application, you send a request in. When that first request comes in and nothing's loaded, it's going to have to pull in some Phoenix modules, it's going to have to pull in some plug modules. If you use the enum function, that's going to be pulled in as well. And that's going to make your first request like quite slow. So when you do a mix release, that is all preloaded for you, so that doesn't happen in your production environment. Oops. I had to go back. And then finally, the release comes with some helpful management scripts, or really one main management script with a couple different options. That's how you're going to actually start the release, which of course is necessary. But then there's some nice debugging features that are kind of included in that, and we're going to explore that in a demo a little bit longer, or a little bit later. And I should say that the first half of this is about releases, and I'm going to kind of just walk through one locally. And then doing a deployment is really just the same thing that we're doing locally, but put on your continuous integration or continuous deployment pipeline. I gotta move Zoom here. There we go. Okay, so mix release. It's a built-in command. You can run it, and for the most part, it's pretty simple. But what actually happens when you do a mix release? Well, the first thing is that, of course, your code is going to be compiled. This is just a little sample project, so there weren't many files, but they're compiled into my app. The next thing is that your configuration is going to be sorted out based on the environment that you set. And then finally, it's going to build you a folder that contains your release, and that's pretty great. And if I open that in my editor, I can see, oh yeah, there's the folder. It's under the _ build, and then in this case, dev, and then the release is in there. And you see REL or for rel, and then the name of my app is just release example. But kind of the most important part of that whole release is the binary that gets built for you. You can see it's all of these commands all reference the exact same thing. And that's in there as well, that release example binary. And that is on the last slide of what I was alluding to with some of the management scripts, that is kind of like the management script. In the documents, it was said plural management scripts. This is the only one I'm aware of. And then the reason it says dev everywhere is because by default, or mix release is just going to use whatever mix env you are working under. And by default, I think it is just development. Here's an example where I set the env to deploy, and now everything is going to be deployed. That's probably what you're going to want to do when you're actually building your release for production. So let's take a look at what that binary is and kind of what it can do for us. So if I run this command on the bottom here, what I get is, or if I run it without any commands, I guess they call them, or arguments, I get a list of all the different options. And I haven't used all of these, but there's some that I use a lot more than the other ones, and that's these ones. Start, well, I guess I don't use the start command that much, but when my CI and CD pipelines do my deployment, they're going to call the start command and actually start my application. The two commands that I use the most in my day-to-day are remote and version. To do both of these, I would have to actually connect to the machine first that my Elixir application is running on, and then I could interact with it by either running remote or version. So version is just going to give me the version, which is surprisingly helpful because sometimes what is running there isn't what you think should be running there, and vice versa. So it's good to just quickly get the version. But far more often than that, I'll be using the remote command, which actually allows me to remotely connect to my application, and you pretty much just become another process node in your supervision tree, or another application running in your Elixir service is a better way to put it. So let's step through a quick demo of kind of what that looks like. Basically all the same stuff. So the first thing I want to do, mix release. Oh, since I've already have done a release with this version, it asks me if I want to overwrite that, and I say yes. So it should compile. Cool. Same thing. If I just run this command, I get the list of all the stuff, and we'll do start. I guess I should make this a little bigger for everybody. Cool. And then you can tell that it's working because, well, I added a lot of it. So starting the application. So similarly over here, if I want to actually connect to it, I'll run the same command, but then pass that remote parameter instead. And now I'm connected to the process. You can see that if I listed out the node name here on the left, I would get this. It's the release example, and it's running on my MacBook Pro. So I can do whatever I want. This is just an IEX shell. So I can require a logger, and I can say logger.info, hello from remotes. Zooms in the way again, from remotes. Cool. So on the right, I get the return value of a logger statement, which is going to be the OK atom. And I actually do get the standard input over here, but kind of more interestingly, it comes out over here because this on the left is where the application is actually running. So that's where the standard out is actually going to go as well. Let me open up another tab. So this application doesn't do much, but there is a small API in there. So I can curl that and I get back hello Toronto. So that's not that interesting, but one interesting thing is that once we're connected remotely, we can also redefine modules, or we kind of do whatever we want because it's just Elixir code. So one thing I do really often when I'm doing my debugging is I hot reload modules just via this remote IEX stuff. I think people talk about hot code reloading on the fly and stuff, and this probably isn't exactly what they mean, but I think there's some of the same mechanisms at play here. So if we just take a quick look at the API, this uses the built-in inets module just to have a really simple API without having to pull in some dependencies. And then this is pretty much my router. I just have one route that's just at the root, and I send back a 200, and the message is just going to come from this module just because it's easier to show for this demo. So right now we're returning hello Toronto. If I say hello world, I'll just save that. Saving this in my editor isn't going to do anything, but if I just copy the whole thing and paste it in, we'll see that I get back some compiled representation of the module, I guess. And then over here on the left, we're going to see a warning saying redefining the module response. So I guess that's a warning. It's expected. Like I expect to see that when I redefine my module. So now if I send in a curl request, this time I'm going to get back hello world because the code underneath us has actually changed. So this isn't something that I advise you do all the time in production, but is certainly quite handy in staging, or if you're on some sort of staging environment where going through the little bit of ceremony to connect to your application once, and then hot reloading modules like this can often be a heck of a lot faster than changing, committing, pushing to GitHub, waiting for something to publish, then deploying that, yada, yada, yada. This is something that you can do a lot faster. And yeah, I think it's just kind of one of the cool things that you get for free with a release. I'll go back to my slides now. Present. Cool. So yeah, this isn't going to be very long. We're already halfway through or more now. So now, how do we deploy to production? It's really the same steps that we did, but now kind of done, automatically for you and spread out over all these different things. So I can't actually show kind of real code examples from PagerDuty because I'm not allowed to do that kind of thing. But this is generally how it works. We start with GitHub. GitHub's going to send some webhook to CircleCI. CircleCI is going to make a Docker image, and that's eventually going to run on Nomad. And Nomad is, like our container orchestrator. It's like a competitor to Kubernetes, I guess. I've never used Kubernetes, but I've used Mesos and Nomad. Cool. So step one, GitHub. So GitHub doesn't do much. I push my commit to my PR, and that's just going to trigger the CircleCI pipeline. This isn't a screenshot of one of my repos, but just, you guys are probably familiar with these kind of checks and stuff. It's going to kick off some sort of CircleCI job, and that's really all GitHub knows about it. More interesting now is when we get into what the CircleCI job does, or rather jobs, because they're plural. The first thing is that we have some orbs. I guess orbs are kind of like packages for CircleCI. And we have two that we use. I actually don't really know that much about the Git one, but I know a little more about the Elixir one. And these are actually public. I think all orbs are public. So if anyone wants, you can just go search like PagerDuty Elixir GitHub orb. And it pulls in some nice stuff that has to just make some Elixir stuff a little bit easier. So, right. So when the commit comes in from GitHub, when the commit comes in from GitHub, there's two jobs here. And the first one is just the build and test. So this is the same kind of mix commands you would run locally. So I want to set my mix environment to be test. Checkout, that would come from the Git orb, I guess. And then these Elixir ones would come from the Elixir orb. So the first thing I want to do is install everything. What I mean by install everything in this case is install Elixir itself and Erlang. What our orb is quite opinionated, and we use ASDF, which is a tool to manage like Elixir Erlang versions. Well, you can manage Ruby and all that sort of stuff too, but it became very popular with Elixir. And you just kind of include a file. It's called .tool versions in your repository, and then ASDF just knows to look at that file for the versions you want and install those. So that means locally we specify the versions, and those exact same versions are going to be here to test our code and to build our code. So we have the same version all the way through, which is obviously something that you want. The next thing that happens is that we do a mix compile, we get the dependencies and everything, or sorry, we get the dependencies and compile them. Then we actually compile the code one extra time, and with the warnings as errors flag. This is something that's specific to my team, but I think is quite handy. We don't want too many warnings making it into production, because sometimes you start with one or two, but then before you know it, there's like 100, and it can snowball quickly. So we catch them here at the CI level, as opposed to doing it all the time locally, because you might be doing some refactoring where of course some warnings come up, because I've seen other people alias their mix compile command so that locally you would run into this error, but we prefer to put it at the CI level. And then finally we do the test itself, and that's kind of what this job does. And then we have another job, which is the actual publishing of the Docker container, because what our container orchestration needs to run is a container. And this, you might notice some similar steps here. We're going to install Elixir again, and we're doing the dependencies again. And the reason we do that is because both of these steps run concurrently, which I think leads to better performance. We're already getting into here like a little bit of like the bespoke stuff. Like there might very well be a better way to do this. This is how we do it, and it works pretty well for us. So anyway, for the Docker publish, similar, we got some more mix commands. First, we're going to set our environment this time to deploy. So I'm going to pull in the config, my config mainly for deployment. Some similar steps here, and then we're getting interesting, or where things get different from the previous one is now we're actually going to run some release commands. So this particular example is a fake umbrella app. And when you have an umbrella app, at least how we have ours configured, you release each piece separately, because your umbrella app might have a lot of apps. Elixir, let's rewind. If you have an Elixir project, which is an umbrella project, you might have many apps in there, right? But maybe not all of the apps actually need to be deployed to production. You might have just like some shared app, or some, your database app or your repo app that is just used by other apps in there. So this way you can specify just the ones you actually want to build for production. So this will release it will create a release for each of those apps. And then I finally want to do the Docker stuff, where I'll just make some tag, probably based off of the GitHub SHA. and then build that Docker image, and then push that Docker image to my image repo. So let's take a quick look at the Dockerfile, because that's kind of interesting. Here is kind of a toy example I made. The really important part is that we're going to pull in the release that we've made. And as you recall, that was under build and then whatever mix env and then release. So I'm just going to stick that in the Docker image release. And then I'm just to start it, I'm just going to do what I did locally, where I called that binary and hit start. And yeah, this is again what the file structure looks like, except the file structure looks slightly different for an umbrella app. In the past, there was only one folder here under umbrella, but now we have two because I released two different apps. So this code here on the right actually wouldn't actually work for this example. And what instead we do is this: we introduce a small little start sh shim, and then instead of invoking the release directly, we just call our start script. And what that start script does is not very much. It takes a command and it's just going to pass that through. So again, start or remote or some of the commands we looked at. And then it looks for an environment variable to be set, and it needs to be consumer or API or whatever the app is we want to run. And then it's just going to basically construct the path and run the thing. So here on the right, I've expanded the release a little bit. So if I step back, so at the top level, there was API and consumer. And then if you blow up each of those API and consumer, you can see they each have their own binary. And those are basically what we're doing here on line 14 is just constructing the path to that, where the app name appears in the path a couple times. And that's most of our apps are umbrella, or most of our projects are umbrellas. And this is the way we found that has been pretty good to start them. So to recap, we make one Docker image that has all of the apps in it. I have seen people make one image per app, but this is just easy enough. It's not hard to set an environment variable that just basically says which one you want to start. And that's where this pretty much almost ends, because that's where things get very specific to the container orchestration that you're working with. On Nomad, they have Nomad is made by a company called HashiCorp, and they have their own kind of proprietary markup language. It's .hcl, which I think stands for HashiCorp language. And then they give you kind of different stanzas and stuff to set environment variables and that kind of stuff. So I didn't do that for this talk, because I think most people probably don't use Nomad, and it's not the interesting part of this talk anyway. But I did have a couple of gotchas that I wanted to bring up. The first is about config and how to organize your config a little bit, because I'm pretty opinionated about this, because we've done a lot of different things, and this one seems to work the best. So the main thing is to use the releases config file, because it is optional, but I think highly recommended and should almost be enforced at this point. So what it's for is the things that you want to get at release runtime. I think a lot of people get tripped up about when some of this configuration code actually runs. And the confusing part is that it's different for each config file. So if I were to put this system fetch environment variable on the right in my regular config file, then that would be run at compile time, which really trips people up. And I think there's almost never a reason to do that in your config file. Any variable that you're going to get at compile time should pretty much be constant. Like, you should be able to know that. Maybe you have some exceptions for running tests or something like that. For the most part, the rule we stick to is anything that's fetching an environment variable goes in the release file, and anything that's static is going to go in the config file. So in this example here, I'm actually configuring the same dependency, but instead of having one big block in either of the two files, we split it up so that any of the dynamic stuff will go in the releases file, and anything that's constant in the config file. So in this particular example, the dynamic things are going to be getting some host and some port, maybe from console or something, or Nginx or whatever, when we're actually running in production. And the static thing is just specifying some adapter that just points to one of my modules. That's not going to change based on the test environment or based on if we're on staging or productions. That is just constant and always going to be there. So we hard coded in. And where that can really bite you is when you do this on line 4. You should not do this. I've seen this one bite a lot of people. And it's, again, because it is confusing about when some of this stuff gets invoked. So this at host, like this construct here, this is a module variable. The name escapes me, but I'm about to show a screenshot of it. And this happens at compile time. So again, if you're using application get-env and this is pointing to your config file, which is grabbing an environment variable, that's going to happen at compile time, which you don't want. So there's no reason not to do this. This is Elixir is a functional programming language. It doesn't hurt to introduce a function. On top of that, I've seen people on the forums ask, how do I access my module dot, at host from another file? Well, you can't, but if it was a function, you could call it and then access it. So yeah, module attributes, that is what they're called. So this is the little blurb about them on the Elixir website. And I think it's kind of interesting how they refer to them. And they say they have 3 purposes. So right off the bat, they're not just constants, they do other things. So number 1, everyone's probably seen like the @doc, like adding annotations and stuff. That's probably the most common use case. Number 2, they work as constants, fine. And then number 3, they're used a lot during compilation and macros and stuff like that. But I just want to point out that even the section that is constants, it's in quotes, like as constants, like it's kind of, the double quotes is kind of suspicious. And then they go to give examples about how they're even not really constant. So in this example, they have a module attribute my data that they redefine, not a constant. And here it shows that how it can change. And then if you're doing, this comes up more like in meta programming, but you can even accumulate these. So here, not only is it not a constant, but the type is even changing. Now we have a list. So this is just really to illustrate that I really don't think you should use these as constants and just use functions instead. It's just easier. The last couple things for gotchas, the build environment and the runtime environment of your release need to be the same. I kind of glossed over this a little bit when I said we use ASDF to ensure that the Elixir and Erlang versions are the same when we develop, when we test, and when we build. That is true, but we also need to make sure like the underlying operating system is the same, because the release is going to target whatever system it was built on. I think that's just like a historical artifact of Erlang. So luckily for us, CircleCI just uses like Ubuntu, and it's not hard to have a Docker image that's also Ubuntu. So it happened once where someone was like, why isn't this working? And then we learned it, and now we know. And then this one's a little more interesting, but you need to think about how your orchestrator, how it restarts things, and how that is going to interact with how your Elixir supervision strategy is going to restart things. This has never really bitten us per se, but we've made some nice improvements here. An example of that is, say when we start up an application, when we deploy it to Nomad, it's coming up. If we can't, actually I should rewind. We don't change our supervision tree in our code so much with Nomad in mind. I think that would be a bad idea. But with Nomad or container orchestration, you do kind of have an extra layer of a supervisor. You kind of think of it that way. So one way we take advantage of that is in one particular case, when our application comes up and say we're trying to connect to like Kafka or like a database, and we can't. And the supervisor there will fail quite quickly. Instead of trying to retry for a while, we specify like a slightly different supervision strategy. So that will bubble up to Nomad really quickly. And then Nomad is just instructed to retry once immediately. I think with a lot of container orchestrators, you also kind of establish some sort of restart policy. You say, oh yeah, try for a minute or try 5 times. But we say just nope, try once immediately to see if it's something weird or funny going on. And if not, kick it to another machine right away. Because we have seen kind of like network errors that might come up, or for some reason, some host just cannot connect to some other host. And it happens. I mean, we have a couple hundred hosts probably, so who knows if they can all, I mean, in theory, they should all be able to talk to each other, but in practice, that doesn't seem to happen that often. So that's kind of an example of how you can take advantage of your orchestrator restart policy along with your supervision strategy. And that's the end. Yeah, like I said, it was only going to be about deployments and it seemed way too short. So I included that bit about mixed releases as well. Hopefully people found that interesting. And yeah, now we got some time, like Matthias said, to have a discussion. I think there are certainly other ways to orchestrate all this stuff. This is not the best way, but over 3 years of working with this at PagerDuty, this is kind of where we've landed as a pretty good way. No single team is responsible for owning this. So we're not constantly iterating on it, but when someone reads a blog post or gets inspiration from elsewhere, then we try to iterate and make it a little bit better. But I wouldn't be surprised if someone out there has a tip or trick for one or all of these steps in the pipeline. So anyway, thanks, and now we can chat.